is vertical. Other one is horizontal. Right? These are the two reactions we will have for this hinge support. Okay, and you can able to see that there is a roller support here, and this roller is inclined at 20 degree with respect to x-axis, which means I will have the reaction perpendicular to this. If that is horizontally 20 degree, this is vertically 20 degree. This is vertically 20 degree. So this is my another reaction. You can able to see here. This is another reaction, right? So let me name this. So because there is no naming here, so for better understanding, I am going to name this. So let me consider this as point A, this as point B, this is point C, point D, point E, and point F. Right? Wherever your UDL starts, wherever it ends, and wherever your point load is there, I am giving that as some points. So A, B, C, D, E, and F. So this one you will have CY and CX. So there are two reactions at C, right? So that support C in support. So you have two reactions, CX and CY. Similarly, here you have FY. You have FY, which is inclined 20 degree with respect to vertical, right? Okay. So what is my next step? So the next step is identify if we have any inclined force. If you have an inclined force, resolve that inclined force. Okay, you resolve all the inclined force. Similarly, if you have an inclined distance, you make this horizontal and vertical distance. Right? These are the two steps we are going to follow. So in this case, there is no inclined distance, so no need to worry about it. But you have inclined forces. You have to resolve all that inclined forces one by one. Okay, let me do one by one. First, this 100, I am resolving it. I will get 2, right? 1 like this, another one like this, right? So this is bringing it downwards. Your angle is decreasing, so cos. So this is 100 cos 30, right? So 100 cos 30, it is around 86.6 Newton, right? So this one is 100 sin 30, which is nothing but 50, right? So this is nothing but 50. Now I'm going to resolve B at point B. Again, I have two forces, right? So one like this, horizontal force. Other one is inclined vertical force. So we are resolving that inclined force. Okay. So horizontal 70 sin 45. What is 70 sin 45? 49.49, and this is also 49.4. Right? Any doubt on this?
No, sir.
Okay. Now you have one more inclined force here. So in this roller support, it is inclined, right? So that also I have to resolve. So I have one like this, vertical, other horizontal. So vertical, it is cos 20. So Fy cos 20. Horizontal, it is Fy sin 20. So what are the values here? Cos 20. What is the value for cos 20? 0.93. So this is, what about Fy sin 20?
0.34.
0.3420.
0.342. Yeah, thank you. So, okay, now I resolved all my forces. Is there any other force? It is not given. So I think this value you consider as 10 Newton per meter. Okay, this is not given. I am considering that as 10 Newton per meter. Okay, yeah. So that's it, right? That's it. So if you want, I can also convert this UDL to a point loop. So for better understanding purpose, you can also do that. So in that case, what you will get, I will get one vertical force, which is 10 into 0.6, right? So 10 into 0.66, 6 Newton, where it will be acting at the distance of 0.3 and 0.3, center. The distance of 0.3 and 0.3, right? So these are all my forces. I resolved it, right? So any doubt up to this?
No, sir.
Okay. Now what I do, I have to put it is in equilibrium condition. In that case, I can say that sigma fx is 0, sigma fy is 0, and moment is 0. Let me put sigma fx is equal to 0, right? So sigma fx is equal to 0. Add all my horizontal forces. So from A, I'm starting from A. A is having one horizontal force, which is 86.6. So 86.6. B. B is having one horizontal force, 49.49, opposite direction. So minus 49.49. C is having one horizontal force, Cx, so plus Cx. D, E doesn't have having. F is having one force, which is 0.342 Fy. 0.342 Fy. Right? I am having that one. Right? So that I have to consider. So minus 0.342 Fy. So this is equal to 0. Right? In that case, I am getting an equation. So Cx minus 0.342 Fy is equal to the remaining, whatever you can put it on the other side. So what you are getting? Minus 37.11. So this is equation number 1. Right? So this is my first equation. Right? Okay, this is over. Next, I'm going to consider Fy and I am going to equate it. So we put sigma Fy and then we equate it to 0. So A, one vertical force, upward direction, 50, positive. So 50. B, another vertical force, upward direction, positive, plus 49.49. Plus 49.49. C, yeah, Cy is another force, plus Cy. So D and E is converted to one point load, which is 6 downward direction. So minus 6. F, one more force, which is 0.939 Fy. So plus 0.939 Fy. So this is equal to 0. Right? So again, I can equate it. So I can put it as Cy minus plus 0.939 Fy is equal to the remaining, whatever we have.
Minus
So remaining,
93.49.
so minus 93.49. Very good. So this is equation number 2. Right? So these are my two equations when I take forces. Any doubt up to this?
No, sir.
Okay. Next, I will proceed with moment. Right. So I will proceed with the moment. So I am going to do it here. So where I have to take moment? The point where I have maximum unknown. So my maximum unknown is at C. So which means I am going to take moment at C. And I am going to say that it is C 0. Right? It is an equilibrium condition. So if I take moment at C, so you have to look after all the forces one by one from A to F. Right? You will look one by one. Okay? First one. So let me consider A. Point A is having two forces. First, horizontal force 86.6. Distance from this 86.6 to C. how much it is? 0.4 and 0.4, totally 0.8. So rotation, it is rotating in clockwise. So minus 86.6 into 0.8, right? Force into perpendicular distance. If I consider this vertical distance, it doesn't have distance. So vertical force doesn't have any distance. So leave that. So A is over. Let me go for B. Again, this vertical force doesn't have distance up from C. Leave this. This horizontal force, you have a distance of 0.4. Right? Rotation, anti-clockwise direction. So force is 49.49. So plus 49.49 into 0.4 into 0.4. Right? That is over. Next, this point, D and E, in between D and E, you have 6 Newton. So this 6 Newton is having a vertical distance, which is 0.6 and 0.3. So totally 0.9. Rotation clockwise. So minus 6 force into perpendicular distance is 0.9. Right? So 0.6 plus 0.9. So this is over. Let me go for this Fy, F point. Two forces. This horizontal force doesn't have distance. Horizontal force is 0. There is no distance given. So this becomes 0. But vertical force, it is having a distance. What is the distance? 0.6, 0.6, and 0.6. So 1.8. So totally 1.8 meter. So this rotation, when it sees it is rotating in anti-clockwise direction. So it is plus 0.939 Fy into 1.8. Right? So force into perpendicular distance. So this is equal to 0. This is equal to 0. So now you have all my only Fy is pending. So you can identify what is the value of Fy. Find out what is Fy. Yeah, you are getting 32.47 newtons. Any doubt in this?
No, sir.
Okay. So since I got this value Fy, I can substitute it in equation 1 and equation 2. We'll identify what is the value of Cx and Cy. Let me substitute in equation 1. By substituting equation 1, what you'll get? Cx is equal to minus 37.11. So this becomes plus, right? Plus 0.342 into Fy. So Fy is 32.47. So minus 26 Newton. So which means the direction what you assumed is a wrong direction. It should be in other direction, right? Okay, very good. So this is over. Now we'll proceed with next one, equation number 2. So Cy is equal to, so minus 93.49 minus 0.939 into 32.47. So what is the value of Cy? So minus 123.9 Newton. Any doubt? Any doubt in this particular problem?
No, sir.
Yeah. So moment of a couple or a couple. So couple is a force. There are two forces actually, right? Which is having same magnitude but in opposite direction, right? And it should be a parallel force, right? If you have two forces parallel, if you have two forces parallel, so the magnitude is same. So magnitude is same. If one side is F, the other side is also F, right? And the direction is in opposite direction. It forms a couple, right? It forms a couple, right? So the formula for couple is force into distance between the two forces. So if I consider there are two forces here, so if I consider here, So there are two forces, F1, F1. So the distance between these two forces is D1, right? So F1 into D1 is my couple. Right? Similarly, F2 into D2 in this case, that is your couple, right? So whatever the location of this couple, so it will be always be same, right? Because it is something which is making your object to rotate, right? It is something which makes your object to rotate. So the moment is based on a particular point, right? So if my force is different at some other point, your distance is varying, right? So for example, let me consider you have an object here. So this is my point O. If this is my force F, right? And let me consider the distance is 1 meter. So moment at O is F into 1, right? F into 1. But what happens if my F is here, right? Your distance is also changing. It is 3 meter now, right? It is 3 meter. So my moment at O is different, F into 3, right? It is changing one by one. So if your force is changing, your moment will change, right? The value of the moment will change. It is purely depends on the distance, right? That is not applicable for a couple. Why I am saying that? Let me consider. So same concept. Okay, so I will erase all these things. Now let me consider you have an object here, right? I am having 2 points. Let me consider this is point A and this is my point B. You have a force here which is 10 Newton, another force here which is 10 Newton. You know that these two forces are parallel, opposite direction, and same magnitude, which means it forms a couple. Right? So I may consider this is 2, this is 1, and this is 2. Right? If I take moment at A, right? So there are two forces. One is distant, other one is distant. Distant is 10 into 2, right? 10 into 2 plus this one is 10 into 3. So totally, what you will get? You will get 50. Right? So what happens if I take moment at B? What happens if I take moment at B? So this one is 10 into 3 plus this one is 10 into 2. Again, you'll get the same 50. So if it forms a couple, in between any point in that couple, your moment is always same. There is no difference in your moment, right? So moment is always same. So A point, B point, even if we consider C point, which is at the center, you will get the same thing. So you will get same 50, right? So that is the importance of couple. Whereas moment is only one force. So if the location of the point location is changing, what happens? Your moment value will also change, right? So that is important thing. Okay, so example of this moment you can able to see. So you can able to see that you have a lever which is rotating. So you know that there is some force required to rotate this particular handle, right? So wherever you hold your hand, for example, in case 1, you are holding it inside. In that case, you require a force to rotate this, right? It is what? So the force what you apply is 40 Newton. The distance between the two forces is 0.3. So totally 40 into 0.3, you are getting around 1.2, right? You are getting around, sorry, 12. I think it is 12 Newton meter, right? 12 Newton meter. But what happens if you hold in some other location, higher location? Your distance is 0.4, but the force what is required is lesser and compared to this. In the 40 தேவை, இங்க வந்து 30 இருந்தா போதும், right? But the force, the moment is same, 12 Newton meter. So actually we call this as a couple. So the couple is same, which is 12 Newton meter, but even though you shift your location, right, the force is lesser, and you know that it is somewhat at any location you will get the same value of this moment. Okay, so this is what we call as a couple, right? So where you use this, right? Where you use this? Let me consider you have a force, right? So I am having a force at point A, right? I am having a force at point A, right? So this is my force. Can you shift it to point B? Is it possible? Yeah. So you can shift it, right? You can shift it. So what is this principle? Unit 1. We call it, yeah, very good. So this is principle of transmissibility. Yeah, this is principle of transmission. We can shift my force so from point A to point B, right? So, but if I consider something like this, your force is here, right? So can I shift it to point B? In that case, yes, we can do that with a forced couple system. You can shift it, but it forms a couple and a force, right? How to do that? Simple. I'm going to add and subtract the same force here. So whatever we apply this force, I'm going to add and subtract at point B. When you do that, what happens? I can consider this two. What is this? It forms a couple, right? So two parallel forces, opposite direction and same magnitude. It forms a couple. So what happens? I can shift it like this. So a force and a couple, right? So this is what we are going to do in this in other problems, whatever we see, right? So what we are going to do is I am going to shift my force from one location to the other location, right? So for that, what you have to do, you have to take a resultant of that, or just take moment. You can shift it directly, right? That is the best way to do that. Okay, right. So here also, so you have a post, right? So a signal post. So if I want to shift this, you can shift it to that location, to the corner point, with what is the weight of the object and what is the couple which is formed on it, right? So these are some examples which is applicable, right? This is applicable for this application. Right? Okay, let me consider this. So you have an horizontal forces, right? So which is P 600 and 400. So they're asking you to identify the resultant of these forces, right? Resultant of this process and the distance from the ground. What is the resultant distance from the ground, right? Okay, so they are given some conditions. So what happens if your P is 200? What happens if P is 2400? And what happens if the P is 1000? So let me consider the first case. Let me consider if P is 200. So what I can say that my fx is equal to 0. I can add it. What I can say, I can add it. So 200 positive, so minus 600 and minus 400, so totally minus 800. So that are my overall forces. Right, that is my overall forces. Next, let me consider here. I'm going to take moment at point D. Right, if I take moment at point D, what happens? 200 into distance. Distance is 150 plus 150 plus 150. So totally 450. So 200 into 450, rotating in clockwise, minus. Others are anti-clockwise. So 600 into 300. So 600 into 300, right? So we are writing in meter, so it is 0.3. Okay. And similarly, 400 into 150. 400 into 150. So this is my overall moment. Right? So now I want to identify the resultant. Where is my resultant? My resultant is here. What is the value of my resultant? 800. Any doubt in this? Resultant is 800. Any doubt in this?
No, sir.
This one. This one. Negative indicates opposite direction. Right? So this is 800. So if I take moment, this moment should be equal to this value. Which means what I can do, I can write it as 800 into, I don't know what is the distance. Let me consider the distance is y. So 800 into y should be equal to 150. This 150. Right? So what is your y? So 150 divided by 800. What is the value?
0.18, sir.
0.18. 0.18 meter. If I write it in mm, it is 180 mm. Right? That is my resultant value. Okay. So can you repeat the same for P if it is 2400 and P when it is 1000? So you will have the difference here. Right? In your resultant, based on the resultant difference, moment will be, I think, of course, moment will also be changed. Right? Moment will change accordingly. So you identify it, find out, and justify. Right? So what happens if the force is changing, whether your distance is changing or not? Right? So I will give this as one more this week problem. Let me consider this one. So you have to replace the problem into a force coupled system, right? At point O. So I have to replace it at point O. Right? இங்க எத்தனை ஃபோர்ஸ் இருக்கு? You have 1, 2, 3 forces. இந்த 3 ஃபோர்ஸையும் ஒரே இடத்துல கொண்டு வரணும். இந்த இடத்துக்கு கொண்டு வரணும். பாயிண்ட் ஓக்கு கொண்டு வரணும். Right? That is my question. Right? So first procedure is same. You resolve this process. Right? If I resolve it, I'll get 3 kilonewtons. So 3 kilonewtons. So when I resolve it, you'll get 3 sin 30 and 3 cos 30. You can able to see it here. And this one, resolving it, you are getting this. So what they have done is cos 30 on the cos 30 3 by 5 அப்படியே போட்டுருக்காங்க. Right? So you can also do something like that instead of resolving it. Right? You know that. So when I bring to the top, so the cos sine. So இப்போ மேல இப்படி கொண்டு வரும் இல்லையா? ஸோ மேல கொண்டு வரும்போது it is like cos theta. இதுதான் thetaனா cos theta வரும். Cos theta opposite side by adjacent side by hypotenuse. So 3 by 5. 3 by 5. அதே மாதிரி இந்த சைடுனா sin theta. So sin theta is 4 by 5. Right? You can put directly. Right? That also you can put. Okay, so this is my for all the forces. Now what I am going to say is I am going to consider sigma fx is equal to what is the value of sigma fx. Don't equate it to 0. So these things is not equal to 0. It's not equal to 0. Sigma fy are all not equal to 0. So because we are identifying the resultant. Okay, so we need the value. So only the value is important. So it means I will directly add it. So 3 cos 30 and 3 by 5 into 5. So we're getting this one, right? In towards positive x-axis. Similarly, when I add all y forces, so 3 sin 30, right? So 4 by 5 into 5, which is negative. 4 is also negative. So you are getting a negative value, which is downward direction, right? So now you can identify what is your resultant. What is the location of my resultant? My location is your x is positive, y is negative. So which quadrant is this? Positive and negative. So it is in fourth quadrant.
Fourth quadrant, sir.
Right? Yeah. So my force is in my resultant force is in fourth quadrant. Okay, you can identify from these things. Right. Now, I'm identifying what is the angle of theta, right, based on the resultant, right? So I identified what is my resultant, right? We know that the angle is, so it is like, so you have one resultant force like this, 5.59. Other resultant force is like this, which is 6.5 kilonewton, right? So the resultant will be here. So it is addition of this two, sigma fx square plus sigma fy square. That is my resultant value. And you have to identify what is the angle theta. Theta is sigma fy divided by sigma fx. Right, that is what we are doing here. Sigma fy is 6.550 and sigma fx is this. Find out what is your angle. So now I got my resultant angle also. Right, so that is my force. That's over. So once I identify what is my resultant value, then I'll go for moment. So I'm going to shift all these forces at point O. So which means I'm going to take moment at point O. Right? If we take moment at point O. Right? So all these forces, for all the forces, moment at point O. So 3 sine 30, distance 0.2. Right? 3 sine 30 into 0.2. 3 cos 30 into 0.1. Rotation is clockwise. So 3 points cos 30 into 0.1. Next, 3 by 5 into 5 into 0.1. Rotation anti-clockwise positive. So 3 by 5 into 5 into 0.1. Next, 4 by 5 into 5 into 0.5. Right? So that is anti-clockwise. So negative. Next, 4 into 0.2. So all these things I am taking moment. I take moment, I will get the value. Right? So now I can replace it. That's it. Right? So what I will do, I have to change it. So before that, I will identify what is my R. R is root of 6.5 square plus 5.59 square. What is your R value? 8.573. 8.573 kilonewton. So I'm going to replace it at this point, which means here you have 8.573. Fourth quadrant, right? It is in fourth quadrant because we already identified. So x is positive, y is negative. Fourth quadrant, your value is 8.573 kilonewton. Angle is 49.3 degree. And you have a moment at this point also. What is the moment? So you have a moment of clockwise moment. Right? You have a clockwise moment of 2.46 kilonewton instant. Right? So we are converted. So all this force is converted to this point. Any doubt on this?
No, sir.
Okay. So that's it. We'll stop here. We will continue in next class.